Hello, family. In this video, we're going to be looking at the rational exponents and surds. The first question, they say write as radicals and simplify as far as possible. Okay, so guys, what does radical means? Ne? A radical basically just means write them in roots to the nth root of something. Does make sense? This is a radical. Ne? Perfect. I'll show you how to convert exponents into radicals just now. But before we start, let me show you the idea of radicals. So this is what a radical is. If I have x to the power, let's say, m over n. I'm sure we agree that on the exponent, m is the numerator and n is the denominator. This is the denominator, right? The n. Sharp. So the denominator on the exponent just tells you what root you have. Ne? If it's n, it means you have nth root. So the denominator just tell you the root. If this was over 2, it means you have a square root. If it's 3, you have a cube root. And then you're going to have x to the power m inside the bracket. Ne? That is just the simple idea of converting exponential expressions into radicals. Okay, so let's try this one. So I see that, okay, here my denominator is 2. It means I have a square root. So I'll just write a square root. Remember, square root, we don't show the 2, it's just hidden, but it's there. So it's a square root of 18 to the power of 1. Do you see it? And then this will obviously become, remember, you can break 18 into 9 times 2. Why am I breaking it into 9 times 2? It's because I have a square root and there's a perfect square that can go into 18, which is 9. So you need to know your perfect squares, which is 1, 4, 9, 16, 25, 49, 64, 81, 100, 121, 144, and so on. Okay, perfect. And you also need to know at least few of your cubes. These are cubes. Okay, these are perfect squares. These are cubes, ne? Perfect cubes. It's 1, it's 8, because 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, 125, and so on. Does make sense? Perfect. Okay. So we're going to do this one. So on this one, right, the denominator is 3. If the denominator is 3, it means you have a cube root. So remember the 3 you show. So you have a cube root of negative 125 to the power of negative 1. Okay, so we have converted into the radical. Now we need to simplify. So to simplify this, we are firstly going to change this into prime base. Remember, I showed you how to do it with a calculator. You type negative 125 equals to shift fact. Also, I don't have to include the sign. You always use that. Then shift fact. So it's 5 to the power 3, which means we basically have, let's see, cube root of, in bracket, negative 5 to the power 3. And then you have negative 1, right? Perfect. And then you have a cube root of, let's see this. Remember, guys, if the outside exponent is an odd number, the negative sign do not disappear. If this was 2, negative 2, this will disappear. So remember, if the outside exponent is odd, the negative remains. If the outside exponent is even, the negative will disappear. So in this case, we are going to have minus 5 to the power negative 3, because 3 times negative 1 gives you that. And then now, because they said I must simplify as far as possible, I see that, okay, this I can actually convert it back to exponential. So which is minus 5 to the power of it's minus 5 to the power negative 3. And then you have 1 over 3, because your root is or is negative, I mean, it's 3. See, so it's a cube. But because there's nothing to put there, you put 1 over. Okay, perfect. And then, so you're going to say, this is basically -5. You could have just said the inside exponent divided by the root. Do you see it? Or you can just simply multiply that. It will still give you that, which is basically -5 to the power -1. Then, ladies and gents, we need to move this down. It's going to give us, this negative doesn't change, né? It's the negative of the expression. So we want to make the exponent positive here. So the negative remains there. Then we move 5 to the power -1 down. It becomes 5 to the power 1. And then here is like we're left with 1. Do you see it? Perfect. Awesome. And then that's it with this question. Okay, let's try number 3. On number 3, you basically have this, ladies and gents. Remember, this means square root. So you have a square root of -81 to the power 1, of which we do not show. Okay, but let me show it in this case, which is therefore non-real, right? Remember, you cannot have a square root of a negative number. So this is non-real. Sharp, you cannot simplify further there. Awesome. And then this one is still a square root. So we have a square root of 4 to the power 3. But what is 4 to the power 3? 4 to the power 3 is 64. Right? 4 times 4 times 4 give you 64. But we all know that 64 is a perfect square. And it's 8 times 8. So which means square root of 64 will be 8. All right. Perfect. And then here, ladies and gents, if you have decimals, you always need to convert them to common fractions. Now, when you're dealing with exponential expressions, so you just press that on a calculator, you press equals to. It gives you 1 over 125. But we know that 125, ladies and gents, is basically 5 to the power 3, right? So it's basically 1 over 5 to the power 3. And then we have to the power 1 over 3. So here I'm going to say, okay, 1 to the power anything is 1. So the 1 will just remain 1. And then this will be 3 times 1 over 3, which gives me 1. So I have 5 to the power 1. And that's my final answer. Do you see it? Remember this? 1 times 1 over 3, it's 1 to the power 1 over 3. But 1 to the power any number in the universe is going to give you 1. And then here I have 3 times that, which gives me 1. So I have 5 to the power 1. And then that's finito. Now let's go to the next part of this video. Okay. The next part of this video, they say simplify the following without using a calculator. So we need to simplify the following without using a calculator. Okay. So to simplify this, we are going to have, let's see. I'm like, okay, here, because I have a minus here, I cannot apply that law that says we need to multiply everything inside with that, right? With the outside exponent. Immediately you have a plus or minus inside, all those rules of exponent, they fall off. You only need to have multiplications and divisions only for the rules to apply. So here I'm going to apply some of my exponential rules that can apply and my algebra skill. Okay, perfect. So guys, I'm going to rewrite this in this form. I'm going to say, okay, this is this. I have 5 at the top. This division line, I'm going to convert it to this, né? And then the denominator, I put it in brackets like that, then minus 9 to the power -1. This is still the same thing. Then I have 5 divided by, in bracket. Remember, the rule says we need to write all as positive exponents. So we can all see that this will be 1 over 4. So I have 1 over 4 there, and then I have minus, this one will be 1 over 9. I'm sure because it was -1, so it needs to be +1. So it has to go to the bottom. And then we have that, right? And then this will equals 5 divided by, remember, ladies and gents, if I have if I have a fraction, I need to make the denominator the same, right? So we can see that, okay, here I'm going to times by 9 over 9, and then that side I'm going to multiply by 4 over 4. And then what is 9 times 4? 9 times 4, I think, is 36. Let's confirm. 9 times 4 is 36, yes. Okay, so at the bottom, we're going to have 36 as our overall denominator. And then 9 times 1 is 9. Negative 1 times 4 is negative 4. And then we close our big bracket. And then we keep on going. The reason why I converted the division line to this, guys, remember this, I converted to this, is because I knew that I'm going to end up with another fraction here. So I'm avoiding having fraction on top of a fraction, you see? So it's always easier to convert to division to avoid any confusion. Sharp. So you have 5 divided by 9 minus 4, it's 5 over, let's see, it's 5 over 36, I think. Yes, 5 over 36, right? And then here I'm going to have 5 divided, now I'm going to convert this to multiply. Ne? Multiply by 36 over 5, right? Then let's see, what does this give us? This gives us a 36, which is our final answer. Let's just confirm. Let's use a calculator and type this and confirm if this is our answer indeed, right? It's always good to just confirm some of your sums. So I have 5, I have 4 to the power negative 1, I have minus 9 to the power negative 1, and then I have close bracket to the power of half. So they say to the power of half. Oh, I forgot the half, ladies and gents. You see? Oh, perfect. I forgot the half. So I need to put the half there. I need to put the half here. I need to put the half. But let's just check our solution first. I have 5, 4 to the power negative 1, minus 9 to the power negative 1. And then, oh, sorry. Then we have that to the power 0.5, which is a half, right? So my answer must be 6. I'm getting 36, which means I forgot something or I made mistakes. You see, that's why it's always good to check. But remember, I had forgot the half here. I had forgot the half. Ne? Remember, half means this is your root. So I have square root of 36 to the power 1, which is basically the 6 that we got when we were verifying on a calculator. That makes sense, ladies and gents. Perfect. Thank you very much for your time and undivided attention during this video. Please don't forget to hit the subscribe button and advise your friends, family members, and anyone that you think can benefit from this channel. Aluta continua. Thank you very much, ladies and gents.